Hello, I'm Professor Von Schmohawk, and welcome to YU. In the previous lectures, we saw that although multiplying natural numbers always produces another natural number, the result of division between natural numbers cannot always be represented by a natural number. For example, if we divide 1 by 3, we must split one unit length into 3 equal pieces. Unfortunately, we don't have any way to represent increments smaller than 1 using natural numbers or integers. To solve this problem, ancient people as long ago as the Bronze Age came up with the concept of a fraction. Historically, the earliest fractions were unit fractions. A unit fraction is a very simple type of fraction. Unit fractions are written as 1 over any natural number called the denominator. We will represent this number with the letter Q. Examples of unit fractions are 1/2, 1/3, 1/4, and so on. The idea of a unit fraction is simple. If a unit length is divided into some number of equal pieces, a unit fraction represents the length of one piece. The denominator tells us how many of these pieces fit into one unit length. Unit fractions were easy for ancient people to understand since they, in effect, undid multiplication. For instance, let's say that you had a plot of land, and your brothers Amen and Hakim also have equal-sized plots. Your brothers decide to give you their land and move to Mesopotamia. You now have multiplied the size of your land holdings by 3. If the pharaoh then took most of your land to build a pyramid, but left you with 1/3, your land would then be the size of your original plot. So keeping 1/3 of your land undid the operation of multiplying your land by 3. To get a better understanding about what unit fractions represent, let's look at unit fractions on the number line. There are an infinite number of unit fractions. Unfortunately, not all quantities between 0 and 1 can be represented by a unit fraction. The Egyptians had a unique way to represent these quantities. If they needed to represent something which was smaller than 1, but was not the exact size of a unit fraction, they would add unit fractions until they achieved the desired amount. However, for some reason which we do not understand today, the ancient Egyptians had a rule that when adding unit fractions, no two fractions which were added could be the same fraction. For example, instead of writing that 2/5 of someone's land was flooded, they would have to write that 1/3 plus 1/15 of the land was flooded. This complicated representation of fractional quantities became known as Egyptian fractions. The Egyptians kept tables to convert various quantities between 0 and 1 to Egyptian fractions. The Rhind mathematical papyrus from 1650 BC contained such a table. This table expressed various fractional quantities as sums of 2, 3, or 4 unit fractions. Unit fractions were the only type of fractions used for thousands of years. Not until the Middle Ages did people start using what were called vulgar fractions. These fractions, which today are called common fractions or just fractions, are composed of 2 integers which we will represent by the letters P and Q. The number on the top is called the numerator, and the number on the bottom is the denominator. We can think of a common fraction as being a unit fraction multiplied by the number in the numerator. In other words, a common fraction is simply a multiple of a unit fraction. As an example, let's take the fraction 3/5. Since the denominator is 5, the unit length on the number line is divided into 5 equal subdivisions. The numerator specifies the number of those subdivisions in the fraction, so the fraction 3/5 would represent 3 of those subdivisions. So in any fraction, the denominator divides the unit length into equal parts, and the numerator specifies the number of those subdivisions in the fraction. In the previous lectures, we have seen that integers are closed under addition, subtraction, and multiplication, since the result of applying any of these operations to integers always produces another integer. However, when dividing integers, the result cannot always be represented by an integer. For example, dividing the integer 1 by the integer 3 does not produce an integer. Therefore, the integers are not closed under the operation of division. To represent the result of division operations, we will have to expand our number system to include fractions. This collection of integers and fractions is called the rational numbers. Rational numbers are closed under addition, subtraction, multiplication, and division. Rational numbers are defined as any number whose value can be represented as a fraction p over q, where p and q are both integers. The value of the rational number is the quantity obtained by dividing p by q. We must add the caveat that q cannot be 0, since dividing anything by 0 is meaningless. Notice that p over q can not only represent any fraction, but can also represent any integer, if we let q equal 1. In that case, the fraction p over q represents the same quantity as the integer p. Fractions can be thought of as ratios. For instance, if two quantities have a ratio of 2 to 1, this means that the first quantity is twice as large as the second. Likewise, a ratio of 1 to 2 means that the first quantity is half as large as the second. So the fraction 1/2 can be thought of as the ratio of integers 1 and 2. In fact, this is where the term rational comes from. Rational number means a number which can be expressed as a ratio. With rational numbers, we finally have a number system which can represent the result of any arithmetic operation. In the next few lectures, we will explore arithmetic operations using various types of rational numbers and fractions.